Now we are going to go through some examples of how to calculate, for example, concentrations of solutions and dilutions of buffers. And the formulas you are going to need for these calculations, there are three different. The first one is that C1 times V1 equals C2 times V2. Where C stands for concentration and V for the volume, and C1 is the concentration of the stock solution that you have. V1 equals the amount you have to take from the stock solution. C2 is the concentration that you want for your solution, your buffer, and V2 is the volume you want to have. The next formula is that C equals N divided by V. That's C is the concentration, N is mole, and the volume is then in liter or milliliter or some other. The third one is that N, that stands for mole, equals mass divided by the molecular weight of the compound. These two last formulas you can combine, because from the first one that says that C equals N divided by V, you get out that N then equals C times V, and if you put this, that N is C, the concentration times volume, at the place of N in the third formula, you see that the concentration times volume equals mass divided by the molecular weight. And if you, for example, then want to know the mass, you see that the mass equals concentration times volume times molecular weight. And a last thing before starting calculation, if you, for example, have 1 liter, then you want to change it to milliliter, then milli is 10 to minus 3, then micro is 10 to minus 6, nano is 10 to minus 9, and pico is 10 to minus 12. In the first example of these different calculations, you have measured 32 grams of sodium chloride, and you have dissolved this salt into 1 liter of water. What is the molarity for the solution? You know that the molecular weight for sodium chloride is 58.44 grams per mole. You know that the volume is 1 liter. You have dissolved it in 1 liter of water. And now you want to know the molarity for the solution. You know that you have measured 32 grams of this salt. You know that the molecular weight for sodium chloride is 58.44 grams per mole. Then you can calculate to know how many moles by dividing the mass with the molecular weight, then N is 32 divided by 58.44, and I always write out the units so I know I get the right one in the end with the answer. I know the calculation is right. And then when I divide 32 gram with 58.44 gram per mole, I get the answer of 0.5476 mole. And I also see that in the end I will have mole. Then what is the molarity of this solution, of this buffer? And molarity is mole per volume. That is the concentration N divided by V, mole divided by the volume. And we already calculated how many moles we have. We have 0.5476, and we have dissolved it in 1 liter of water, so the volume is 1 liter. And then the concentration, the molarity, will be 0.55 mole per liter. In the second example, you should prepare 100 milliliter of a buffer, that is, the volume is 100 milliliter of a buffer containing 50 millimolar of tris, hundred and 50 millimolar of sodium chloride, and 10% of glycerol. And you have 0.25 molar tris, and you have a 5 molar sodium chloride and a glycerol with the concentration of 50%. So now this is a dilution of these 3 different solutions. When you have stock solutions of all 3, and now you need to dilute. And the first is then tris, which you have concentration of 0.25 molar, and you want it to be 50 millimolar. And in this case you can use the formula of C1 times V1 equals C2 times B2, where the C1 is the concentration of the stock solution, which is 0.25 molar. V1 is how much to take from the stock solution, how many milliliters to take from the stock solution. We don't know that, that's why it's X. This equals C2, which is the concentration you want for tris, and V2 is the volume, which is 100 milliliter. And now you see you have C1 as a molar and C2 as millimolar. So now to get the right answer, you have to change the molar to millimolar or the millimolar to molar, so the calculation will be correct. And then if you have 0.25 molar, then 1 molar is 1000 millimolar, which means that 0.25 molar concentration is 250 millimolar. So if we in this calculation, in this formula, instead of writing 0.25 molar, we write 250 millimolar times X is 50 millimolar times 100 milliliter. Now you can see that the units are the same, so now this calculation will be correct. And then X will be 50 millimolar times 100 milliliter divided by 250 millimolar. So now the unit, as you see, will be in milliliter, and you wanted to know what V1 will be, which is a volume, and it will be 5000 divided by 250, which equals 20 milliliter. So you will have to take 20 milliliter tris for your buffer. The second one is sodium chloride. You want to have the concentration of 150 millimolar, and we have a stock solution with the concentration 5 molar. You can again use the formula C1 times V1 equals C2 times V2, where C1 is 5 molar, the concentration for the stock solution. V1 is X, we don't know how much to take from the stock solution. C2 is 150 millimolar, the concentration we want for sodium chloride, and the volume is still 100 milliliters. And again we have the stock solution in molar and what we want in millimolar, so we have to change one of these so they have the same unit. So 5 molar times X equals, if we put 150 millimolar to molar, it will be 0.15 molar times 100 milliliter. Then X will be 0.15 molar times 100 milliliters divided by 5 molar. And now you see again that the unit in the end will be milliliter, because molar and molar, so we will in the end have milliliters, so the X will be 3 milliliters. The last thing to put in the buffer is glycerol, and we want the buffer to contain 10% glycerol, and we have a glycerol with the concentration of 50%. And we can again use the formula C1 times V1 equals C2 times V2. C1 is 50%. Which can also be written as 0.50. And V1 is X. We don't know how much to take from the stock solution. C2 is 10%, which also can be written as 0.10 times 100 milliliter. And now we have both the percentage as decimal, 50% as 0.5 and 10% as 0.10. So now when we calculate this, what the X will be, we see that X will be 0.10 times 100 milliliter divided by 0.5. So the answer will be 20 milliliter. We need 20 milliliter glycerol from the stock solution. And now we then put 20 milliliter tris from the 0.25 molar stock solution. And 3 milliliter sodium chloride from the stock solution of 5 molar, and 20 milliliter of glycerol from the 50%. And this equals 43 milliliters, 20 milliliters plus 3 milliliter plus 20 milliliter. And the total volume will be 100 milliliter. And these tris sodium chloride and glycerol together is 43 milliliters. So then we will add 57 milliliters of water into the solution. In the third example, the molecular weight of a certain compound is 180 grams per mole. And you want to make a solution with the concentration of 5 millimolar. How much would you need of the compound for a volume of 250 milliliter? So the molecular weight is 180 grams per mole. The concentration is 5 millimolar. The volume is 250 milliliter. What is the mass? How much would you need of the compound? And now we can use the formula C equals N divided by V. That is, the concentration is mole through the volume divided by the volume. We know the concentration, that's 5 millimolar. We know the volume, which is 250 milliliter. So we are calculating the N. N equals concentration times volume. That is 5 millimolar, 5 millimole per liter times 250 milliliter. And now we have 5 millimole per liter, there is liter, and then we have the volume in milliliter. Now we have to have the same unit, so the answer will be correct. And 250 milliliter, if we say it in liter, so 1 liter equals 1000 milliliters. Then 250 milliliter will equal 0.25 liter. That's the calculation will be 5 millimole per liter times 0.25 liter. That gives 1.25 millimole. The unit will be millimole. So now we also know the mole. We have 1.25, and we want to know the mass. So now we know, then we can use the formula N equals mass through molecular weight, which means 1.25 millimole equals X divided by 180 gram per mole. And then X will be 1.25 millimole times 180 gram per mole. And now you see that we have the first in millimole and the second one in mole. We have to have the same unit, either millimole or mole, to get the correct answer. And then X, if we change 1.25 millimole to mole, then this will be 0.00125 mole times 180 gram per mole. And now you see we have mole and mole, so the unit in the end will be gram. So 0.00125 times 180 is 0.225 gram. You can also, in this example A, you can combine the two formulas C equals N divided by V and N equals mass divided by molecular weight. And we can change in the first formula where the concentration equals mole through volume. We can also calculate out the N or the mole. Then the N will be C times V, and put it in the second formula where N equals mass through molecular weight. Then this N in the second formula will be C times V equals mass through molecular weight. And in this 3a we want to know the mass. Then 5 millimole per liter times 250 milliliter equals X through 180 gram per mole, X divided by 180 gram per mole. Then the X will be 5 millimole per liter times 250 milliliters times 180 gram per mole. And now we have millimole and mole, and we have liter and milliliter, so now we have to change this so the answer and the units in the end will be correct. So the X equals 0.005 mole per liter times, instead of writing 250 milliliter, we'll write it in liter. That will be 0.25 liter, and this times 180 gram per mole. So in the end we will have gram as unit, and the X will be 0.25 gram, exactly the same answer as in the previous calculations. And in 3b, what is the concentration of the compound in microgram per milliliter in the solution? We have 0.225 gram per 250 milliliters. Then if we divide 0.225 with 250, it will get 0.0009 gram per milliliter. And 1 gram equals 1000 milligram, and 1 milligram equals 1000 micrograms. And then 0.0009 gram equals 0.9 milligram per milliliter. And now we want to know how many micrograms we have per milliliter. 0.9 milligram is 900 microgram per milliliter. In the next example, we are going to make a solution with the volume of 100 milliliter. This solution will contain 1 time PBS and 20% glycerol. And you have 10 time PBS and you have 50% glycerol. And what we have to do is to dilute the stock solutions that we have, we can do that but by using the formula C1 times V1 equals C2 times V2. And first we're going to dilute the PBS, and the concentration of PBS which we have is 10 times. We don't know how much to take from the stock solution. We want the concentration 1 time and the volume of 100 milliliter. And you'll see now that the concentration for the PBS is 10 times stronger than what we want it to be in our final solution. And also in this case you can use the formula C1 times V1 equals C2 times V2. So this formula for dilution can be used for molar concentration from 10 times and so on. And the X will then equals 1 times 100 divided by 10, and that gives 10 milliliter. We're going to take 10 milliliters of PBS. And the next one is the glycerol, and it's also a dilution, so we can use the formula C1 times V1 equals C2 times V2. And the glycerol, the stock solution, is 50%, and we can write the percentage as decimal 0.5 times X, because V1 we don't know how much to take from the stock solution. C2 is 20%. We want the final solution to have the concentration for glycerol to be 20%, that's 0.20, and the volume was 100. As with the PBS, it's the same solution. So then the X will be 0.20 times 100 divided by 0.50. So the X will be 40 milliliters. So we will take 40 milliliter of the glycerol from the stock solution. So finally we take 10 times PBS from that stock solution. We will take 10 milliliters from the stock solution of glycerol. The 50% is glycerol. We will take 50 milliliters, 40 milliliters. And this together will be 50 milliliters. And the final volume is 100 milliliters. And this PBS and glycerol now takes up 50 milliliters, so then we will add 50 milliliters of water. In the fifth example, so you need 500 milliliters 20% magnesium chloride. How much magnesium chloride do you measure? This is a percentage calculation. So and if you have 100%, that means 1 kilo per liter, or 1,000 grams per liter. 500 milliliters equals 500 grams, and 20% of 500 grams will be 0.20 times 500 grams, which means that you are going to need 100 gram magnesium chloride to make this buffer. And in this case, there were no water molecules bound to the magnesium chloride. That means that we can directly calculate 20% of 500 grams, which is 100 grams. If there is water molecules bound to the salt, you have to take that into your calculations, and that means it will be a little bit more than 100 gram.